Hey everyone, welcome back, and today let's solve Leetcode problem 2275, titled Largest Combination with Bitwise AND greater than 0. So the bitwise AND of an array nums is the bitwise AND of all integers in nums. So for example, for when nums is equal to an array of 1, 5, and 3, the bitwise AND of nums is equal to 1 and 5 and 3, which is going to yield an output of 1. And for another example here, when nums is equal to an array of length 1, having an element of 7, the bitwise AND of that input array nums is going to be 7. So we're given an array of positive integers candidates, and we need to evaluate the bitwise AND of every combination of numbers of candidates, and each number in candidates might only be used once in each combination, and we have to return the size of the largest combination of candidates with the bitwise AND greater than 0. So in example 1, we have the input array candidates to be the following, and we output 4. Why is that? Because the size of the combination, the size of the largest length combination that has a bitwise AND greater than 0 is going to be 4, right? And that combination in this case is going to be 16, 17, 62, 24. Why? Because the bitwise AND of 16 and 17 and 62 and 24 is equal to 16, that's greater than 0, and 4 is the longest length of any combination with a bitwise AND of all of its numbers being greater than 0. And it actually can be shown, they say in the problem explanation, that there is no combination with a size greater than 4 that has a bitwise AND greater than 0. And note that more than one combination may have the largest size. So for example, 62, 12, 24, and 14, and 62, 12, 24, and 14 has a bitwise AND of 62 and 12 and 24 and 14, which is equal to 8. And since although that's still greater than 0, this still only has a length of 4. It's still equal to 16, 17, 62, and 24. And so 4 is the length of the longest combination we can have that actually still has a bitwise AND greater than 0. Okay. So in example 2, we have the input array candidates to be an 8, 8. And we simply would output 2. Why? Because the largest combination, 8, 8, is going to have a bitwise AND of 8 and 8, which is greater than 0. And since the size of that combination is 2, which is the longest combination we can make with a bitwise AND greater than 0, we have to return that size of 2. So looking at the constraints here, we see that the length of our input array candidates is not going to exceed 10 to the power of 5, and the candidates at any index I for any element in our input array candidates is not going to exceed 10 to the 7th power. So with that out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem in a few seconds. Okay, so I think the key to this problem simply just lies in understanding what the bitwise AND operation actually is. What does it say? Simply for any two numbers, this AND operation is going to return a number with bit set only to 1, only where both input bits are actually 1, right? And to effectively maximize this subset size, where all of the AND results of operations are actually greater than 0, we have to basically find the bit positions with the highest number of 1s across all the numbers in our input array nums, right? So to kind of just structure our solution, we're simply going to count first how many times each bit position is set to 1 across all the numbers in our input array candidates. And then from there, we simply have to determine the maximum count from these bit positions, which is also going to tell us the largest combination size. Right, so to do this, I'm just going to use an array. I'm just going to call it bit counts, and I'm going to use it to store these set bits at every single position or index in our input. Right, and from there, we're simply going to iterate over each value and simply check, is each bit position, whatever it is, and update our bit counts array. And effectively, after that for loop is done, we simply have to return the maximum value in the bit counts array. Why? Because that's going to represent the largest subset size. So with that out of the way, let's just go ahead and dive straight into the code here. Like I said before, I'm going to initialize my bit counts array. And it's going to be initialized to 0 times 32. Basically an array of size 32 with 32 zeros. Okay? Right? And what is it going to do? Why do we actually initialize it to 0 times 32? Because that's going to represent each bit position in our typical 32-bit integer, right? There's 32 bits for every single typical integer size. That's why we're multiplying this by 32 for an array of 32 zeros. And it's simply going to store at each index how many times each bit position is set to 1 across all the numbers or values in our input array candidates. Okay, so once we've actually initialized our bit counts array, now we can begin iterating through all of the different elements in our candidates array. So I'm going to say for number in candidates. You can say for candidate in candidates. It doesn't really matter. I'm going to say for number in the candidates array. I think that's how you spell it. Okay, I should be right. And we'll have a nested loop to iterate through every single bit position for that current number. And this is simply going to be in the range of, again, you guessed it, 32. Why? Again, because we simply have to check if each bit at the bit position is set to 1, right? There's 32 bits in this typical 32-bit integer, right? And so we have to iterate through all the different bit positions or indices in the range of 32 for this current number in candidates. Okay, so once we do that, now we have to check if the number anded, I don't know if that's the word, simply using the AND operation, by 1 shifted to the left by the current bit position. If that's true or equal to, well, 1 in Python, we simply have to increment our bit counts array at that bit position, right, which again is going to iterate through all the different bit positions in the range of 32 because the length of each input integer is going to have it 32 bits at bit position, and we have to increment it by 1, plus equals 1. So what are we doing in this main chunk of code here? What does this kind of signify us doing? Okay, so first of all, we have to iterate over every single number in our input array candidates, and for every number, we have to check every single bit position, because again, it's 32 bits, in the range of, like I said before, 32. Once we check that, now we actually have to check, is the bit at bit position currently set to 1? How do we check that? We simply have to use this number anded by 1, which is going to basically have an operation that shifts a 1 left by bit position, which is going to create a mask to isolate that specific bit. And if this operation, or I guess expression, evaluates to true, also equal to 1, then it means the bit is going to be set, and so we can increment the count in that bit count array at that bit position index by 1, right? And effectively, outside of this for loop here, we simply have to return the maximum value of our bit counts array. Why do we have to do that? Because after processing all the numbers and at each index in our bit counts array, that's going to represent the count of set bits at that bit position across all the numbers. And so to find the largest subset, or I guess combination size, we have to return the maximum value in our bit counts array, which is going to represent the largest count of numbers with a 1 at a specific bit position, right? Which again, we compute at every single number in our candidates array for all the different bit positions for that 32-bit integer size, right? So as you can see, if I were to submit this, unless I made any syntax errors here, this should be accepted and this should be a valid solution. And as you can see, it is pretty efficient. So basically, to reiterate, what does this code do overall? It's pretty straightforward here. We simply have to scan every single bit position for every single number in our input array candidates and simply sum up how many numbers actually have that set bit, or rather that bit set, right? And the result is going to be, the result is that the bit counts reflects the counts of ones across all of those bit positions, and so we can find that maximum count, where again the count is going to correspond to the largest combination of numbers in that array that share at least 1 bit in common in their bitwise AND operation, which we compute right here on line 6, right? Shifting 1 bit position to the left, okay? So for the time complexity of this program, this is going to be a big O of n times 32, or 32n. Pretty self-explanatory, n is going to be the number of elements in our candidates array. And why is that? We have to check each of the 32-bit positions, or bits, for each number, which is going to yield to a linear time complexity with a constant factor of 32. So technically, the time complexity of this would be big O of 32n, right? 32 times n. But again, 32 is a constant in time complexity and memory complexity. We don't care about constants, and so this is going to simplify to big O of n, a linear time. We got the 32, but how do we get the big O of n? Again, this is simply a one-pass solution, excluding this constant iteration of 32 of the number of bit positions. Why? Because we simply iterate over every single number in our candidates exactly once. It's a one-pass solution, and so this is going to be a big O of n runtime complexity, right? Big O of right? Linear time, right? And for the space complexity, this is going to be big O of 1, or a constant time solution. Why? Because really we're only using a fixed size array. Bit counts is going to have 32 elements, right? So regardless of how big our input size actually gets, we're only using this bit counts array of size 32. It's constant, and so this is going to be a constant time memory placed solution. And so that's going to make this solution very efficient even when we have really large inputs for our candidates, because it scales linearly with the number of elements. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.